Okay, hi, hello, welcome to another tutorial, and today I'm going to be going over the super large class in FTCLib known as the motor class. It is absolutely massive. Um, so I guess let's get started. And so the motor class, it's large. It's got a whole lot in it. I'm not going to cover stuff such as encoder, the encoder subclass, and I also won't go over a huge amount of controllers such as PID and feed forward, but I will touch on them. And so to get started, so first you want to say, hey, I've got a new motor and it's called David. So there's your motor David. And so then you got to import the class. And so what does David equal? David equals new motor. And then hardware map. And to make a basic motor, all you have to do is just hardware map and name it. So I'll name David Goliath, I don't know. And so this is how you make a basic motor. However, there are a few other parameters that you can input if you have a different kind of motor. So such as go builda. So if you have a go builda motor, it's got a bit more, it's a bit different. So then you'd put after the name, comma, go builda, and dot any one of these RPMs. If you've got 30, 435, bare is 6,000, 84, 117. For now, I'll put 435. And if you want to see all the different RPMs that there are, just control click on go builda, and there it is. 30, 117, 1150, 1620, bare, as I said, is 6,000. I don't know why you'd put none. And so yeah, that's the go builda motors. Now, if you're not using a go builda motor and it still doesn't specify the exact rotations per minute or counts per revolution, you can do that yourself by doing, for counts per revolution, I don't know, 117, and then you'd put the RPM, so like 645. And that's not right at all, but it's a good example for it of what you do. And so for now, I'm gonna just leave it as go builda, because I personally use go builda motors. And so that's how you create the motor object. And then so let me quickly do wait for start and while op mode is active. I went over this kind of stuff in my creating your first op mode video. And so doing stuff with the motor. So you do your motor name. So in this case it's David, and then dot. And if you want to set the power of it, so this goes between -1 and 1. So if I want it to, I don't know, go at half speed, in whatever direction you have, 0.5. So this will be going at half speed, whatever direction the motor considers forward. And then if I wanted to go in the reverse direction, -0.5. If I wanted to go to max power, 1.0. Max power the other way, -1.0. Now, if your motors are inverted, a simple thing you can do is motor name dot set inverted true. And what this will do is it will make the motor go in the opposite direction. So For instance, I'm not saying it's going to do this. Your motors may be different. For instance, I had it set to -1 before. While this is false, you don't have to put .set inverted false unless you put true at some other point and you want to change it. While this was false, this would, for example, in this situation, it would be going counterclockwise. But if I were to make it true, now it's going to be going clockwise. And that's all the inverted does. It makes the motor go the opposite direction that it initially was going. It's like it switches the negatives and the positives. And so another neat thing you can do, instead of saying your motor name .set 0 to stop it, another thing you can do is, after it's been running, you can just do stop motor. That's like saying set power 0, except it's much clearer. It's like stop the motor. And that's all like the basic stuff for the motors. That's like the most basic motor breakdown. And so then you start getting into the complicated stuff. So here we are, my motor named David. And so there are 3 different run modes for motors. There's raw power, position control, and velocity control. The default, which I pretty much just demonstrated to you, was raw power. All it really is you can set the motor between -1 and 1 for power. That's about all it is. There's no complexity behind it. It's basic. You don't need anything else. Just the motor, connect it, set the power. The other 2, however, are much more complicated and require a bit more knowledge on PID control and that stuff. As well as you're going to need an encoder wire plugged in to your motor. These will not work properly unless they're receiving feedback from the motor. And the only way they can do that is if you have a second wire plugged into the motor, which is known as an encoder wire. And so, velocity control. I guess I'll start with velocity control. It's pretty simple. First thing you gotta do is this dot set run mode, and then whatever run mode. So motor dot run mode, and then dot, and then you can see position control, raw power, velocity control. So starting off with velocity control, in my opinion, it's more complicated. So then what you have to do is set the coefficients. So David dot set velocity coefficients. And so what this kind of is like PID. This is PID. If you don't already know what PID is, it takes in this thing called error, which is like the difference between where you are and where you want to be. And it takes in this error, and it's like, and it has 3 different numbers, which you'll have to tune. So like continuously test with these different values. And you'll have to say, so firstly, P. What is P? P keeps the motor proportional with the error. So it's like, I want the motor to be moving proportionally with the error rather than going all out of sync, and it's not even like keeping track at all. So I don't have a set value for this right now, so I'm just gonna put 0.1. I kind of like stops it from overshooting. So this is typically a higher number. In my experience, this is a higher number than the others. And then you have D. D kind of keeps the error constant, so it's not oscillating as much, like giving you these large amounts at random points. So that is also typically kept really low, in my experience. And so once you have those, you can also set feed forward coefficients. And so to do that, you just do David.set feed forward coefficients. And what these are is like, it's like saying where you want to go and where you are. It's like feed forward is a bit more complicated in my opinion, mostly because I haven't worked with it as much and it's not as big of a thing. But essentially what it is it's like you put in static gain, which is kind of like sensitivity a bit of the motor. And so I guess for this I'll put 0.92. And then you also have to put in velocity gain, which is kind of self-explanatory, gain of velocity. So I'll put 0.47. This will help it from not overshooting. And then all you have to do, David.set, not 9, 0.9, I don't know. And then typically what you like to do, I didn't mention this earlier, but it's good to put stop motor after your while loop, so it doesn't continuously run after it. And so what this is doing is this is helping it maintain, like, this is controlling velocity. Self-explanatory in the name. I'm saying, hey, go this velocity, and maintain it. So it's good for stuff like shooters. And so next we have position control. Now position control I like to use a lot. It's really good for saying, hey, I want you to go here. And so first thing we'll do is set the run mode. Motor.run mode dot position control. And so position control. First thing, so this mostly uses P control. So it uses the proportion of PID. And so first thing you gotta do is motor.set position coefficient. And this is like the P. So I'll put it as, I don't know, 0.3. Now again, you'll have to tune these numbers. The numbers I'm not putting are the exact numbers you need. You'll have to continuously test and tune. It's good to start with lower numbers so you don't freak out. And so next you have to set the tolerance. So that's like the maximum error allowed. So dot set position tolerance. And so typically I like to set this around 10. If I want a bit more of an exact value, I'll set it to 5. If it doesn't need to be super exact, maybe you could set it higher, like 20, something like that, or 50. But more exact numbers, probably 10. And so you'll also need to set the target position. I don't know, 5,000 ticks. You can see how far that is for your specific motor. It's different. And so then all you have to do is David.set however fast you want it to go to get there. 0.5 half speed. And another thing that's also good to do is if you're using position control in this while loop, you can say and while the motor is not at the target position. So it'll say so as soon as the motor reaches target position, this while loop will exit and your code is finished. That's pretty much all that does. And I also like to do the stop motor after, so the motor stops, obviously. And that's pretty much it for the motor class. There are a few other things, such as zero power behavior, which consists of brake, unknown, and float. break kind of like says stop, and float says, okay, you can stop after like, I don't know, a small bit of like the robot decelerating, floating kind of. And so that's really simple to do. You just have to do motor name dot set 0 power behavior, and there's also unknown, but that just is the exact same as float. So, and then you just put motor dot 0 power behavior dot break, for instance. And that's a very simple self-explanatory thing that you can read more on. I will put a link in the description for GM0 as well as the FTCLib documentation for the specific of the motor class. But that's pretty much it for the basics of the motor class. A few complex things, but really are quite simple when in the long run.